Hi guys, today we are going to do, it's a pretty short video, number 38, solve equations and inequalities. Solve equations and inequalities with technology. So the technology we're going to use, just like we did in the other video, is desmos. It just makes it much easier to find what's going on. So the same thing we did with desmos, to solve with desmos, www.desmos.com. To solve with desmos, guys, we're going to basically do the same thing, except we're going to set the left side of the equation, y equals the left side of the equation, and then y equals the right side of the equation. And then again, just like we did in the last video, number 37, we're going to find the intersections. So if it's an equation and it's an equal, it's just going to equal that exact x value. But if it's an equality, we got to think about it a little bit. And when we get to one, I will show you. So the reason we need to know this is some of these, you just absolutely would not have the tools to solve these right now. So e to the power of 4x minus 3x equals 9. Most of you probably don't even know what e is. E is a value kind of like pi. We'll learn a little bit more of it when we do logarithms. But if you actually look on your calculator and you go to, it's right above the division sign, second function e, it is a value of 2.71828. So it's kind of like pi, and pi is 3.14 and so on. So it's a value in mathematical terms, and it has to do with natural logs and logarithms and stuff like that. So we'll talk about that later on. But anyhow, you all would have no idea how to solve that. So what you would do is you would take the left side of the equation and put it in desmos, y equals e raised to the power 4x minus 3x, and then y equals 9. So let's go over to desmos and put those in. Y equals, now watch what happens when I hit E on my, if I just hit E, you see how that comes up, y equals 2.718. So it already knows what E is. So we're going to raise that to the power of 4x and then arrow over to bring it down, minus 3x. So look, that's kind of like a parabola, but not quite. And then y equals 9. All right, so if I go, and here's y equals 9. So if you click on one of them, then it'll show you, so if I click on this one, no matter which one, it'll show you, you just need to be clicked on one of the graphs, and it'll show you the intersections. So we have, look, I have negative 3 and 9, and then 0.595. So my x values are negative 3 and 0.595. So it's just like we did before. So let's go back here, and we're just going to make a little rough sketch of what that looked like. It was kind of like a lopsided U thing like that, and then the 9 went straight across, so we had two solutions, and our x values were negative 3 and then 0.595. So those are our solutions. If I was to plug, I can show you. If I was to plug in the negative 3 here, if I said e raised to the 4 times negative 3, 4 times negative 3, and then minus 3 times negative 3, that should equal 9. and it's really close. And the reason it's not exactly is because E itself is an averaged, they have to round it, the 2.7. That goes on to infinity. So it's not going to be exactly 9, but it's going to be close to 9. So it's an approximation. Okay, next one. If we have a problem like x squared plus 4x equals x plus 6. So we're going to put y equals x squared plus 4x, and we're going to do y equals x plus 6. Now, let me show you what it's going to look like, and then I can show you what we did before and what's going to happen with that. So y equals x squared plus 4x, and then our next equation is y equals x plus 6. And then let me go out a little bit, and I can see my two solutions. And I have a parabola. I'm just going to draw this on my graph real quick. And then I have my x values are negative 4.372 and 1.372. Okay, so look. So I just drew a little parabola with a line going through, and those are my two solutions. Now, just to show you all what we would have done before I wanted an exact value. So before, what we would have done is we would have brought everything to one side. Since it's a quadratic, I would subtract x, and I would have plus 3x minus 6 equals 0. There are no factors of negative 6 that would give me a 3. So I'd have to use my quadratic formula, and I would have x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. And I would end up with negative 3 plus or minus the square root of 9 plus 24, which is 33, but let me make sure, 33 divided by 2. Now that is an exact answer, and that's what we had to have before. But let me show you, if I actually do the math on those, if I do negative 3 plus the square root of 33 and then divide all of that by 2, look what you get, 1.372. That's what we got there. And then if we did negative 3 minus the square root of 33 and then got an answer and divided all that by 2, we get negative 4.372. So these are approximate solutions. This is an exact solution. So you have to be very careful. If I ask for an exact solution, this is what I want, and you would have to do the quadratic formula. An approximate solution, then you can use desmos and look at your answers. Of course, if I ever had you have an exact solution, you could always check it using desmos, like actually find the decimal values of this and see if it is the same thing as your desmos. So there you go, right there. A little way of checking yourself. Number 3, if you have the opposite of the absolute value of x minus 2 on one side and negative 1/2 x minus 2 on another side, it would be above your pay grade right now in order to do this. So again, you would just put it in desmos. So y equals the opposite of, and then absolute value x minus 2, and then you would have y equals negative 1/2. So I'm going to put that in a fraction. Negative 1/2 x minus 2. Move this down, and here we go. There's one solution. Here's another solution. So one of them is at 0, and the other x value is at 8. So 0 and 8. So we're going to draw what it looked like. It'll look like that. So we have x equals 0 and 8. And those are our two solutions. Because otherwise, you guys wouldn't have the ability to solve that right now. All right, now this one is a little bit different. We have x squared plus 6x plus 5 has to be greater than or equal to 0. So let's graph that and see what actually happens. So x squared plus 6x plus 5. So you're going to have, you would just have y equals x squared plus 6x plus 5, and you would have y equals 0, because sometimes there might be something else over there. But watch this. So the wording is what matters here. Y equals x raised to the second power. So x squared plus 6x plus 5. And then y equals 0. But that really matters. But look. Let's zoom in on this. Look where it crosses the x-axis at -1 and -5. So that's where it crosses y equals 0 at -1 and -5. Okay, so that's important. Now let's go back here and let me show you how we need to think about this. So 1, 2, 3, 4, 5. All right, so at -1, 2, 3, 4, and -5. And here's what the graph looked like, okay? All right, so here's the thing. They want to know, when is this greater than or equal to 0? Well, when are those y values higher than 0? So you're going to come here, and it's going to be here and here. So it's kind of like, in this case, you're going to think of it like, where is it positive? Where is it above the x-axis? Because the x-axis is y equals 0. So where is this above y equals 0? Well, think about it just like we did when we had positive and negative, and we're going to write it the same way. So one way we could write it is when my x values are less than or equal to -5, when my x values are less than or equal to -5, and when my x values are greater than or equal to -1. Greater than or equal to -1. To write it in, so that's using inequalities. My brain wasn't working. Okay, we could have also said -infinity to -5, and then -1 to infinity. You have to be able to write it in both, because sometimes they might ask for an inequality, sometimes they might ask for interval notation. But that is literally when is this graph above y equals 0. And it's above when y equals 0, when x is less than or equal to -5, and when x is greater than or equal to -1. So these, you have to think a little bit. The inequalities you have to think a little bit about. Next one, number 5. X plus 3, when is that greater than 7 minus 3x? And I'm not going to put that. I'll just show you what it looks like. What is going on? Let's do a whole new page. All right, so number 5, sorry. X plus 3, when is that greater than, oh, that's what it is, 7 minus 3x. I had something under my paper. All right, so here's what this one looks like. You're going to have a graph going, x plus 3 is going to look like this, and then 7 minus 3x will actually look like this, and they're going to cross right here, and this is at 1, 4. 1, 4. Okay, so they're going to cross at 1, 4. So here you have your x plus 3, 1, and here you have your 7 minus 3x. So the question is, when is this graph greater than this one? Well, here, you're thinking about the y values. These y values are all smaller than this graph until you get to here, and here they're equal. So here they're equal, and then from 1 on, when x is greater than 1, then this graph is bigger than this one. Then this graph is on top and this one's on the bottom. So the x plus 3 is on top and the 7 minus 3x is on the bottom when x is greater than 1. So here is when it's greater than 1. When that graph is greater than this graph. So your answer would be when x is greater than 1, or you could say 1 to infinity, and it cannot equal, it's not equal to, it's just greater than. It's a weird greater than. So both of these answers would work. There's your inequality, there's your interval notation. 2 more real quick. Number 6, x squared plus 2x minus 1. When does that equal? The absolute value of x plus 2 plus 2. There's no way you all would have the skill set at this point to solve this. So what you would have a parabola, and then you would have an absolute value. They would intersect. And in this case, if you were to put them in desmos, they would intersect at negative 3.30 and 1.79. You can put them in desmos to see that. So you would say y equals x squared plus 2x minus 1, and you would say y equals x plus 2, absolute value of x plus 2 plus 2. And that's what the graph would be. Up here you would have y equals x plus 3, and then y equals 7 minus 3x. And then look at the intersections. Okay, one last one. Number 7, if you have 2x squared minus 3x, when is that less than or equal to 1/3 x plus 3? 1/3 x plus 3. All right, so if we were to put this side in desmos, y equals 2x squared minus 3x, I know that's a positive parabola. And then y equals 1/3 x plus 3, I know that's a positive linear equation. But I've already done the work, so I put it in desmos, and I have a parabola, and here I have this line. And here you have your intersections. But I want you to see this. This x value right here is 2.315. And this x value right here is negative 0.648. Here's the question though. When is the parabola less than or equal to the line? So literally they want to know when is the parabola below the line? When is the parabola below the line? Well, it's below the line in this section right here. So it's below or equal to the line when 0.648 is less than or equal to x is less than or equal to 2.315. There it is as an inequality. In interval notation, you would have negative 0.648 to 2.315 and then bracket. So there it is as an inequality. Here it is in interval notation. But it literally wants to know when is the parabola less than the line. So it dips below the line between those 2 points. Okay, so that's your notes.